In this lecture, we study Zener diode. Zener diode is a heavily doped semiconductor material. And here you can see the appearance of the Zener diode. It looks like this. And it allows the current in both the direction. It allows the current in both the direction. And we use the Zener in the reverse bias, and that too in the breakdown region. So what is this breakdown region? We will study in the VI characteristics. So when we apply the forward bias to the Zener, what is forward bias? Connecting positive plate of the battery to the positive material of the PN junction diode and negative to the negative. So this is the forward bias Zener circuit diagram. Now we try to analyze the operation. Here this is a P material and this is the N material. Junction is formed, and after that depletion region also forms. Because of this already we have discussed in the PN junction. Now, because of this forward bias, when this depletion region offers some potential, here negative ions are formed, here positive ions are formed, and it offers some electric field. So when we apply the forward bias, and here in the P region and N region, free charge carriers attains the high energy, and it will try to cross this junction, thereby what? So here the current flows in this loop. This operation is similar to the normal PN junction characteristics. Now here you can see this is 0. As you go on increase the forward voltage, so here across the diode also voltage increases, and a small current flows, and where the current increases abruptly, that point is called the cut-in voltage or diode forward voltage. Now here the sudden current is increasing. So as you go on increase the supply voltage, the current increases in this loop, that is here. Now here you can see here. And across the voltage, almost the voltage is constant. This is the forward characteristics of the Zener. It is same as the PN junction. Now if we apply the reverse bias, then so reverse bias means connecting negative plate to the positive material and for positive plate to the negative material. So now here also I'm applying the reverse bias. If you apply the reverse bias, now here the depletion width increases, and here minority charge carriers are very less minority charge carriers are there. And as you go on increase the supply, so because of this minority charge carriers, a small leakage current flows in the Zener, like a PN junction diode only. So this already we have studied in the PN junction diode. And here also a small leakage current is flowing. As you go on increase the reverse bias, at one point, here more number of free charge carriers induces in the P region and more number of free charge carriers induces in the N region, that leads to very high current. Now that you can see. So this is called the breakdown region. So that voltage is called the breakdown voltage, where the sudden current takes place. So that voltage is called the breakdown voltage or Zener voltage. So here in the Zener diode, this breakdown, two types of breakdowns are there. One is avalanche breakdown and another one is a Zener breakdown. So avalanche breakdown means if you take the P and N material, now this is the P material and this is the N material, and here as we go on increase the negative supply, so this depletion width increases, and here in this across the depletion width, here negative ions are formed, here the positive ions are formed. Now here this is the atom is having the free charge carriers, and a small amount of negative minority charge carriers are there. Now these are the atoms, and a small number of minority charge carriers are there. As you go on increase the reverse voltage, because of this high voltage, reverse voltage, these my charge carriers, free charge carriers, attains the high mobility. Free charge carriers attains the high mobility by increasing the voltage. Voltage is increased, thereby free charge carriers attains the high mobility. Mobility increases, and with this high mobility, it go and collide with the atom. So from this atom, more number of charge carriers induces. So collision is taking place, thereby more number of free charge carriers are generated. And again, these free charge carriers also attains the high mobility, and it will go and collide with other atoms, and more number of free charge carriers generated. Like that, what this collision takes place and free charge carriers increases in the p material and n material, and these free charge carriers leads to high current. So this is about the breakdown region. Because of the external supply, the charge carriers attains the high mobility and collision is taking place. Collision means what? These charge carriers will go and hit the atom, thereby more number of free charge carriers generates, and it is in the continuous form, and thereby very high current free charge carriers are generating, and this leads to the high current. So there's in a PN junction also, PN junction diode also, I have explained the breakdown. And this breakdown is happening in the PN junction diode also because of this avalanche breakdown only. And because of this, in the PN junction, this sudden current, this high current leads to the permanent damage of the PN junction diode. And in the Zener diode, wantedly, we are operating this Zener in the breakdown region. And here in the Zener breakdown, when this current flows, Zener diode will not get damaged because of the doping concentration. Coming to the PN junction and Zener diode, doping concentrations are different. That's why. So PN junction diode will get damaged if this avalanche breakdown occurs. But in the Zener, it will not happen, and we use this as a application. And every Zener, now here Zener breakdown voltages are nearly from 2.4 volts to 200 volts. Every Zener is having some Zener voltage. Zener voltage. The Zeners which are having the more than 6 volts, in that Zener, avalanche breakdown takes place. And the Zeners which are having the Zener voltage less than 6 volts, in that Zener breakdown takes place. And what is the Zener breakdown? Zener breakdown means this is the P material and this is the N material and this is the PN junction. And because of highly doped P and N material, here the depletion width is very narrow. And within the narrow depletion width, if ions are accumulated, and here the high electric field intensity takes place, setups. And this high electric field intensity will try to pull the electrons from the outermost orbit of these atoms, thereby free charge, more number of free charge carriers induces in the P and N material. It leads to a rapid surge in electric current. This is about the Zener breakdown. And we will study the application of Zener in the next lecture.